Welcome back, Math 30-2. Today we're looking at amplitude and period of sinusoidal functions. So that's pretty much looking at the amplitude and period of graphing sine and cosine. Now sine and cosine are very similar. Here's a graph of sine, here's a graph of cosine. For to graph them, the only difference is one's a shift of the other, because they're both looking at our trig circle here, right? From here to here is one full cycle of the trig circle. Now, if we do this, if I take a look at from here to here is one full cycle, if I take a look at this here, when I have 0, when x is 0, so when we're at 0 degrees or 0, that's when our y, our value here is the longest, right? So that's cosine, right? Cosine is my length. My x value, my y value is that. So when I put in 0 there, we end up getting 1. So that's why it starts at 1 and sine starts at 0. So they're really just a shift of each other. We'll get to that later. So now starting off, we're going to look at what is a periodic function. And a periodic function is something that, well, follows the period, like what we did here. So the period of sine, well, there's a whole circle. Once we get to 360 degrees, or 2 pi, that's a whole period. Then a sine will start again, okay? Or if it's just simple sine. Now also, the period is for something to repeat itself. That is what period means. The other thing we're going to look at is amplitude. An amplitude can be described using this function here. It is your max minus your minimum, and then we divide it, because it's the average between max and minimum. So from here and here, we add these together, then we divide by 2. Here we're going to add these two together and then divide by 2. So my amplitude for this is max minus min, which is 10, subtract negative 10. So we go 10. And then we're going to subtract negative 10, divided by 2, which will give me a total of 20 over 2, which is equal to 10. So my amplitude is 10. And what that does is tell us from our flat mid-range, what is the dispersion, or how much it fluctuates from the mid-level here, okay? Or the median. This one here is 6 subtract negative 2, which will give me 8, and we divide that by 2, which is 4. So it's from the median, it's 4 up and 4 down, and that is my amplitude. So think of a slinky. When you wiggle it back and forth, what happens there? When it's just sitting there, that's your median. When you wiggle it, well, how far up it goes from the median and how far down it goes from the median, that is your amplitude. Okay? So it's the distance away from the median. And period is how long it takes for the cycle to repeat itself. For this one here, the period is from here to here. That's our period, right? Because it goes up, down, then back up. There's our period. Or we could look at it from max to max, or we could go from minimum to minimum to find my period. So in either case, we're going to have them all at 0 to 8, which is 8, or 2 to 10, which is 8, or we go from 6 to 14, which is 8. So the period is equal to 8. Now let's take a look at this one. We go from, find the period for this one, we're going from 0 to min, 0 to 6, so we have 6. Or we could go from 3 to 9, which is still 6. And, well, pretty much, or I could go from here to here, which is also going to be 6, but it's a little bit hard to find. So my period for this one is equal to 6, okay? It's just how long it takes for it to repeat itself. Now, then the next part here is going to explore the graphs of y, sine, and cosine, but I have a different activity for us to do this. We're going to be doing this one here. We're going to look at exploring what is, in this case, amplitude. So here we go. I have a secret about amplitude. What is it? So here's sine x, and this is the amplitude of sine x, is 1. Here we have sine pi over x. Now let's see what happens to the, or sine x over pi. The amplitude is still 1. So let's take a look at the next one. We have y is equal to 2 sine x. Here I get my amplitude is 2. Well, that's interesting. My amplitude finally changed. What changed it? Take a look at this one, 0.5 sine 2x. What will my amplitude be? Here, 0.5. My My next one here is y is equal to 3 sine over 10. What do you think my amplitude here is? It's equal to 3, or the amplitude is equal to 3. Take a look at this last one. Maybe you already found the pattern. What is the amplitude? Interesting. So there is my amplitude. So now, can you figure out which variable in the equation, y, is equal to sine x plus b? Which variable here relates to amplitude? I wonder if you could figure it out. Which variable there relates to amplitude, and how does it relate to amplitude? So which variable in this equation, y is equal to a sine bx, relates to amplitude? Okay, so now here's my next one. My next little puzzle for you is about period. So if we look here, we have different graphs with different periods. Let's see if we can figure out what my secret is about period. So here's my equation, y is equal to sine x. What is my period? 2 pi. Well, 2 pi, if I just have sine x, 2 pi is just, well, there's 2 pi in a circle, right? So the period is just the whole circle. Not sine 2x. What's my period here? Pi. Well, that's interesting. My period here is, there's my equation. What do you think my period is going to be? Here's my next equation. Well, that's interesting. It's the same. My period for this one is the same as the period for this equation. Take a look at this one here. That's an interesting period as well. Okay, we have one more. That's interesting. And there we go. So I want you guys now to pause and see if you can figure out what is my secret about period. Okay, and then how does the b value in y is equal to sine bx affect the period? And can you make a formula to find period? So I want you to pause right now and see if you can figure out by yourself if you can make a formula on how to find period. So I gave you a list of equations here, and if you look across, there is the period. So how is it related to period? Okay, welcome back. I hope you found out, and I'm going to give you the formula for period. So period is equal to 2 pi over b. All right? Okay, so now we looked at that. So we figured out something for amplitude, and we figured out our formula for period. Okay, so let's now go and look at this here. We're going to do this first set of class examples here. These are the formulas we were given to earlier, and we know that this one, that period is that. And normally the period is almost done, normally it's done in radians. If it's done in degrees, we use this part here. So here we go. Here is my first set of questions. It says, determine for the following sinusoidal functions the amplitude, the period in radians as a multiple of pi and in 2 decimals, and the maximum and minimum values. Okay, so the maximum and minimum, that is our crest and our trough. So here we go. Y is equal to 0.5 sine x. Well, my amplitude normally is 1 if it's just sine x. So this here is my amplitude. So my amplitude is equal to 0.5. Okay? So now we want to know what is my period. My period is equal to 2 pi divided by b, and my b is 3. So it's just 2 over 3 pi. You could calculate that out and put it into 2 decimal places. I'm not going to do that right now because I just don't have my calculator on. Now let's take a look at my max and min. Well, my max is from 0, 0.5, my max is equal to 0.5, and my min value is equal to negative 0.5. Okay? Let's take a look at the next one. Here we have y is equal to 6 sine 3x. So now we want to find, again, the amplitude. Well, as we found out from our little previous exercise, that 6 stands for our amplitude. So A is equal to 6. My amplitude is equal to 6. Okay? And we could find my period. Period is equal to 2 pi divided by 3. Okay? So what is my max and min? My max is equal to 6, and my min is equal to negative 6. All right, let's try the next one. So it has C here. Now what does that negative do? Does that negative matter? Well, we learned before that negatives, it just means whatever this is, my y value will be negative. So when my y value is before positive on the graph, let's see here, my graph looks, or for sine, it looks like this. So then everything that's positive now becomes negative, and everything that was negative becomes positive. It just flips it. That's what this negative means. We just multiply everything there by negative, and that's what my y value is going to be. So really, it has nothing to do with my amplitude. My amplitude is still 2. Okay? Now we have 0.25. So my period is equal to 2b, 2 pi, all over negative, or just, we could just put negative 0.25, which is 0.25, which is equal to 8 pi. So my period is 8 pi. It doesn't matter if it's negative or positive 2. All that does is flip it this way. Okay? So you don't have to know about that really for this course. Now the next part here is we want our max and my min. My max is going to be at 2, and my min is going to be at negative 2. So those negatives didn't really do anything to max and min or period, or even my amplitude. Okay? So let's take a look here at example 4. Now example 4, we have our graph here, and it says state the amplitude and period. So we know there's an amplitude and a period. So first of all, let's find my amplitude. My amplitude, I look at my max and my min. Well, we have positive 3 and negative 3. So it's 3 minus negative 3 divided by 2. So my amplitude is equal to 6 divided by 2, which is equal to 3. Now let's find my period. My period, to do one cycle, well, it goes from here to pi. My period is equal to pi. Now it says determine the values of A and B. Well, I found A is my amplitude, so A is equal to 3. And now B. Well, we have to take a look at my period, and we're going to switch it around. So B and period are going to switch around if we switch around the equation. So B is equal to 2 pi over pi, because that's my period. So B is equal to 2 pi over period. Okay? So what I'm going to get here is just 2. So now I found B and A. Okay? So it says graph the function on a graphing calculator and estimate to 2 decimals the value of the function when it is equal to that there. So what does my function look like? So my function is just, we put it in here both. So we know A is 3. So we have 3 sine, and my period, and sine 2x bracket. Oh, just make sure my mode is in radians. Window, yeah, that's about right. Oh, I'm going to change it. I want 2, so pi. And I want my minimum 4 and 4. Yeah, we should see everything. So there we go. This over a bit so we can see the graph better. So there's my graph. And now it says we want to know when x is equal to 5 pi over 6. So I'm going to have to calculate that. So we're just going to trace, and we want 5 . So I'm going to trace plot. Sorry about that, I have my stat pun on, I have to take it out. So I'm going to trace, and I'm going to put 5, and we want pi divided by 2. I think that's what it was. Oh, divided by 6. And I'm going to end up getting y is equal to negative 2.6. Okay? So we get is equal to negative 2.6. Okay? Then it says the values between 0 and pi for when y is equal to, this is the same thing as when y is equal to 1.5. So I'm just going to have to go here and go 1.5. And we're going to graph. And we want between 0 and pi. So I'm counting here, if I go to my windows, everything's counted by pi over 2, I believe, or pi over 4. All of these are by pi over 4. So we graph, pi over 4, that's pi over 4, pi over 2, and pi over 3. So pi is going to be right there. So we want between here and here. And we know my period's pi. So we want between here and here. Okay? So it intersects twice over there. So we have to calculate my intersects. So first curve, we want the first curve whereabouts. Whereabouts is my intersect? It's about right there. And I get 1.3. So we have 1.3, and my other value is, go to my intersect. We want my intersect, so we go over, and we hit enter 3 times. I'm going to get 0.26. So those are my two values that we could have at 1.5. We just calculate our intersect like we did before. Okay, last question. It says here, the partial graph shown below represents the function a is equal to sine bt. Okay, that has a maximum of 3 and a minimum value of negative 3. So there's my maximum. So we know my amplitude, a, is equal to 3. Now we want to know what my period is. Well, if I go, starts from here to here, well, that's half of my graph. My graph should continue to there. So if at 6 is half of my graph, then my period is equal to 12. So now we have to try and determine the equation. Now if I know my period is 12, we have to figure out b. b is equal to 2 pi divided by my period, which is 12, which gives me the same as pi over 6. So what is my equation? Y, or f of x, I should say, f of t is equal to 3 sine, and we have pi over 6x. Or, I'm going to write it out better for you, f of t is equal to 3 sine pi over 6x. And that is my answer. Okay? So hopefully you understood this, and good luck on your assignment tomorrow.